In this video, we are going to start discussions on the physical nonlinearity part of the course. The physical nonlinearity relates to the material nonlinearity. First of all, we will discuss the issue of plasticity. Plasticity can then be defined by using an yield function, and then different types of hardening rules can come in within the plasticity definition. The first one is isotropic hardening and the second one is kinematic hardening. And all these will be discussed in terms of an example for a uniaxial stress state. The idea for this video is to get you introduced to the definition of plasticity, what exactly it means, and how the stress-strain behavior changes when plasticity occurs, and that can be defined by means of the yield function. So, plasticity can be defined as a state when deformation is applied on a certain structure, then it cannot be recovered when the loads are removed. So, if you load a certain structure based on a time-dependent scheme, then the structure will deform, but it can deform beyond the point of yielding, where when you remove the load from the structure, it will not go back to the same isotropic path that we have been looking at so far, or elasticity is not maintained. Of course, we use fictitious time increments, and by means of counting these successive increments, we can calculate the stresses and the strains that occur. So there are many different ways of calculating these changes in the physical behavior. And we will consider in this case only one-dimensional elastic-plastic relations, but of course multidimensional relations can be expanded from here on using the similar methods. Now the most important thing that we will do at the end is to bring you in contact with the idea of how this information is actually used in the finite element method.